Hey guys, welcome to Unit 4, Section 2, the second lesson of Unit 4. And we are going to be looking at properties of kites and trapezoids today. And these you're probably heard of before, but are just less familiar than the other quadrilaterals that we were talking about. And these are going to have their own properties. These are not parallelograms, so make sure that you're aware of that because they don't meet all of the criteria for a parallelogram. This is what we look at, or what they look like, the general figure of a trapezoid and a kite. And a trapezoid is a quadrilateral with just one pair of parallel sides. If it has two pairs of parallel sides, then it becomes a parallelogram. Now a kite is a quadrilateral with two pairs of congruent adjacent sides. So before, with parallelograms, we had opposite sides congruent. Now we have the adjacent sides, meaning the sides right next to each other. Now, we have some terminology because we have a special type of trapezoid. This trapezoid is called an isosceles trapezoid. If you think back to when we talked about isosceles triangles, two sides were the same. So if you notice here, DC and AB are the same. And then we still have the parallel sides with the one set of parallel sides. But for this one, the isosceles trapezoid, we have legs are congruent. Oh, before I do this, I forgot to fill in the left side. We got to do that first. Okay, so the legs are the sides that aren't parallel to each other. They're usually smaller, but they don't have to be. Well, kind of have to be. But the legs are on both sides, usually the left and right is what I meant to say. And then the bases are the parallel pieces. So we have two bases technically, and they have to be different sizes. Otherwise, it's not a trapezoid. And then this section here, we're going to reuse an old vocab word, which is the midsegment. It's the average of the bases. So if you add up the value of the bases and divide it by 2, and it goes from midpoint to midpoint, just like a midsegment did before, so that's not anything new. But we get, that's how we can find the midsegment. So the properties here of an isosceles trapezoid are legs are congruent, the base angles are congruent. I'm going to use the symbol here because I'm running out of room. And then diagonals are congruent. Let's just talk about this here. When it says legs, as I pointed out earlier, that would be like AB and DC. Base angles would be these two angles and these two angles. So A and D are a pair of base angles, those are congruent, and B and C are a pair of base angles, and those are also congruent. The diagonals are the distance from B to D and A to C. Their only special property is that they're congruent to each other, so they're the same distance, but they don't bisect the angles and they don't meet at a right angle like the other ones did. Kites, the next part here, the diagonals of a kite are perpendicular, meaning they meet at a right angle. They don't bisect each other the same way that they did before. Technically, this one gets bisected, but these two are not the same. The next thing is one pair of opposite angles is congruent. So these two, C and A, are congruent, but B and D are not. And what we have to remember, and I should have said this earlier, triangles add up to 180. Quadrilaterals, all of them add up to 360. So that's our new magic number for this unit. One pair of opposite angles is congruent, is what I wanted to say here. All right, let's actually do some application of this. First one says find the length of the midsegment. If you recall, we were talking about the midsegment is the average between the bases. So to find average, we just add them up. 15 plus 23, and we divide by 2. So 15 plus 23 is 38. Cut that in half, we get 19. So this is 19. The midsegment always has to be in between the lengths of 15 and 23. Another way to think of it is the distance from 15 to 23 is 8. They have a difference of 8. And then half of 8 is 4. 15 plus 4 is 19, and 19 plus 4 is 23. So that distance has to be the same. Find the lengths for HE and FG. HE is this outside piece here, and FG is this outside piece here. We actually have to use the Pythagorean theorem to find this. It's probably been a little while since you've seen that, but we know that this chunk right here is 5, this part here is 3, and the reason I said we need the Pythagorean theorem is because we have a right triangle. If you recall, you can find missing pieces of a right triangle with the Pythagorean theorem, which is a squared plus b squared equals c squared. So to find HE, we know that the a value we're just going to use is 3 squared, 5 squared, and then c squared is what we're trying to find. So 3 squared is 9, 5 squared is 25, and we get the square root of, I'm jumping ahead. 9 plus 25 is 34. Then we have to take the square root to solve for c, and we get c equals the square root of 34, which would be this side right here. Then we want to do the same thing. I'm just going to do it off to the side here. We're going to use a squared, b squared, c squared, but we're using different numbers. Now we're trying to find FG, so we got to use 3 and 9. 3 squared plus 9 squared equals c squared. 9 plus 81 equals c squared. Sorry about that. 9 plus 81 is 90. And then we take the square root to undo that square. And we get c is equal to the square root of 90. Now let me approximate both of these, because that's probably what I'll have you guys do. And this is approximately 9.5. And then this one is approximately 5.8 if we round just to 1 decimal. All right, so that's how we do that one. And then the last little bit here. So we want to find the missing angle measures. Now remember, the magic number when we're looking inside of a quadrilateral four-sided figure is going to be 360. If you recall, the opposite angles, one pair of opposite angles in a kite has to be congruent. And it has to do with this angle here and this angle here. So those two have to be the same, which means this is 85 right here. This angle is not the same as this angle here. So we don't want to make that 130. They don't even look the same too. We have 85, 85, and 130. To find that last piece, let's just call it x, we know that all 4 angles have to add up to be 360. So if we add, I'm going to add those other 3 numbers. We get 300, so x plus 300 equals 360. Take away 300. And we get x equals 60 degrees. Or k in this sense, I should write k equals, or the measure of angle k equals 60 degrees. Next, we're looking at a trapezoid. Find the value of x. So this time it's a little bit different. If you look, 20 is the mid-segment, and that's given to us, but we don't have the base. So the formula is adding the base together, 17 plus the other base is 7x minus 5, and dividing that all by 2, and that's supposed to equal the mid-segment, which is 20. So if we fill that out, that's what it would look like. So we can do it this way. Combine like terms on the top. 17 minus 5 gives us 12 plus 7x over 2 equals 20. And then we can multiply both sides by 2 to get rid of that 2 in the bottom. You get 12 plus 7x equals 40. Subtract 12. we get 7x equals 28 divided by 7, and we get x equals 4. That's one way we could have done it. Or we could notice that the distance from here, 17 to 20, is 3. So that means the distance from here to here is also 3, making the base equal to 23. So then what we can do is just say 7x minus 5 equals 23. Solve for x. We get 7x equals 28 divided by 7. And again, we get x equals 4. So it works either way. All right, so that is it for this lesson. Go ahead and try the homework that's attached. It's in Schoology in the same folder where you watch these videos. Submit your notes for both videos, but the homework is separate. Let me know if you have any questions.